My name's Jim Warren. I'm with TXAPA. Glad to have you guys here today. The purpose of this program is to go a little bit deeper in the areas of materials, design, construction, and maintenance, just to go a little bit deep there and to talk about these issues and how they relate to each other. Just to let you know that all these programs are recorded and they're posted on our YouTube website. You can go to YouTube, type in TXAPA, and you can see here's our front page right here. You can go down here to the front right here. It says Everyday Asphalt. You can click on that and all our playlist is in there for all the programs that we do. So we're up there as well. The other thing we do is we post these things on Audible or on Spotify and on your Apple Podcasts. You can listen to them in the car. So that's another opportunity as well. Please like, subscribe, and share for this. Again, it's a good resource for you as we move forward. You can, if you missed the program, you can always pick it up on this or pick it up on your Audible system of choice. All right, so let's get started today. So this week or this month, we're doing a little road trip. I've been on the road a bunch for the last month, and I just got back from vacations. And so what we're going to spend some time this morning or today on is just what we've learned and some things that we want to pass on to you guys and to make sure that you're aware of stuff. A lot of new stuff in this business. The industry is always trying to improve. We always got something going on, and that's what makes it kind of fun. Okay, it's not your father's asphalt in many respects anymore. We're able to make a lot of changes and make some significant improvements in the performance of these products. And so again, I want to just, first out, just get going. I mean, we have a lot of designers in here, a lot of materials folks, etc. People are involved in pavement selection, that sort of stuff. And if what you have is not working, there are options. Okay, I just want everybody to make sure you understand that. And if you need some help, please reach out. Okay, we don't know it all, but we know a fair bit, and we know a lot of people that may be able to help you. So don't ever be afraid to reach out. Email address jwarren@texasasphalt.org, and or you can just go to our website. You can find us there. Myself, Chuck, or any of the folks here are always willing to help anybody when it comes to try to improve asphalt. So let's take our first trip. Our first trip was over to Bryan or College Station. Was over there a couple times over the last month or so, working with the Highway Construction Workforce Partnership. What is that? What is that? Well, it's a program. It's in its second year now, and they're just finished its second class. I think last week, while I was away. Yeah, they finished. I think they graduated on Friday. What this is a program to reach out to graduating high school students and people that are young coming into the business and give them an opportunity to learn more about the asphalt industry and learn more about construction in general and specifically the asphalt industry to hopefully push some people into our area. We're all looking for new people. People are retiring. People are moving. We always need new people. We need technicians. We need engineers. We need people that can work the paver and everything else that's out there. So we're always looking for that. So this is an opportunity to take somebody fresh out of high school, for the most part, and expose them to a whole bunch of different areas. What do they expose them to? Well, this is a 6-week, right now it's a 6-week course. It's full-time, 5 days a week, 8 to 5. And they talk about career opportunities, safety, OSHA 10, work zone safety. They get them on equipment. They're running skid steers. They're actually doing construction math. I spent a day with them. We spent a whole day just talking about paving and compaction, how the paver works, etc. And then they take that out into the field, as you saw in the picture, and you'll see some more. Our HMAC group across the street here, they go out and they work with them on soles and base training, level 1B, level 1A. So they're affiliate, now they're exposed to safety equipment, mathematics, the paving operations, the testing operations. They give them equipment operator training on skid steers, brooms, rollers, pavers, etc. They take them to asphalt plants. They give them lab tours. They actually get them in the lab doing some testing. We out on an actual project. I'm going to show you some pictures there in a second, and then they also help them with interviews and life skills and and try to tie these folks up with people that are actually hiring. And so the last group last year, they all got hired, okay, which was great. And this year, we hope they all get hired again, so that will help keep the program running. So this is kind of the part of the end of it. We're kind of wrapping up. We're actually out on a roadway, actually paving. So they, got, conventional paver, a smaller paver, smaller size rollers, because we're doing smaller size stuff. But we're paving full width out on a real road. This is a quarry that goes into a Knife Rivers plant, a Knife Rivers quarry out there in that area. And hey, I forgot, just a really big shout out. TTI, Blinn College, TXAPA, a lot of different folks have put a lot of time and effort into making this program work. And so it's a great opportunity to do that. So we were able to actually out there and help them. And notice the attention to detail. This was a young guy, just got up on the roller. I mean, they had done a little bit of practice, but now he's doing it real time. This is their first effort really, really getting in there and paving, and he's just monitoring, watching, and back rolling a joint properly. And so they focused on giving these guys the attention. This group was all males. Last year they had a mix. It doesn't matter. We need good, capable people in this business to help move things forward. Okay, that's our first stop. Our next stop is, now we're getting back into the material side, which some of you guys may think is a little bit more toward. I'm going to talk about TOM mixes, thin overlay mixes, okay? Part of our arsenal of asphalt mixes that we've got to use, or that we can use in our pavements. We just want to make sure we're using them in the right places. Now, TOM mixes are great mixes, and they've got a great application, but they're not able to be used everywhere. Okay, if you're really standing loads, stop, start stuff, bike paths, bus pads, that kind of stuff, there's other mixes available. But for a preventive maintenance mix or a preservation mix, really top-notch material. And again, we're not staying still. We're trying different things. Now, we've tried warm mix, and we've tried engineered crumb rubber. We've tried high polymer mixes. We'll talk about that in a little bit as well. But this is a project down in kind of San Marcos, moving down towards New Braunfels on an FM road, and they placed a conventional TOM mix at conventional temperatures. I don't have a picture of that, but here's a picture of a TOM mix placed warm mix, and you can see the temperature up here, 229 degrees, and this is just underneath, back behind the paver, so we haven't really got on it yet with the rollers. Obviously, we're putting in a modifier in that material, a compaction aid or a warm mix additive, as you will, to allow us to lay that material at a lower temperature. And guess what? It lays. Okay. Now these mixes get a little bit stiffer in these areas because these TOM mixes got a PG 7622 in it, and so that's a stiffer binder. But with these modifiers, these compaction age warm mix additives, we're able to actually get a little bit more workability at a little cooler temperature. Now, are there limits? Absolutely, on everything. And that's the whole thing about this business, is the business isn't afraid to try stuff. Okay, sometimes it works, sometimes it doesn't, sometimes it's a home run. And so these are just things we're looking for those home runs in there. Okay, so again, we try different things. This is a project. They also tried an engineered crumb rubber. What's ECR? Engineered crumb rubber is a dry rubber product that's added, like an aggregate, into the mix itself. It's not added as a binder. And so the idea there is to get some engineering properties out of that, which will improve performance. And so, again, these are different products that we're trying, and this one laid pretty well. Looks pretty good, looks pretty consistent. But we're going to get it out there on the road, and it's down there kind of in the range where they've got a lot of quarries and trucks and all that sort of stuff. So it'll get a fair bit of traffic, and we'll be able to try that out. So there's another project, and this is kind of a project that's just, and this was kind of fun because it wasn't we're doing things that we didn't really intended to do. Okay, these things, just opportunities came up and people jumped on them, and we tried that. Out on 130, there's a project right now that's ongoing. Okay, and the project is is a concrete rehab, or whatever you want to call it. They've got an existing concrete pavement out there that's had some issues, settlement issues and cracking and patching, and so they went in and they patched the existing concrete, and then they profile milled it. And the folks who did the profile milling did an awesome job. They really, really did a great job. So this is a Lone Star project. Big shout out to Lone Star. These guys really stepped up to the plate. So the project is, we're going to go out and they're going to they did the prep work on the concrete, and then they're going to place a seal coat down. They do a hot apply product down there, and that stuff is not going anywhere, okay? And then they put a tom down there to kind of, again, help level it up and smooth it out a little bit. And then they're going to come back on top with a PFC with the HPG, the High Polymer Binder, in there. So what we were able to do a week or so ago, or I guess 2 weeks now, they did the trial batch for the HPG PFC. But they had some extra binder left over because of how you got to buy that material. And typically you have to buy 3 loads of it, because I have to make that material, and you just can't make a little bit of it. And that's another point as we wrap up I want to maybe hopefully come back to. But so they were doing the trial batch. So we had an opportunity to use some of that leftover material to do some other stuff. So here's what it looks like on the roadway. Okay, here's our seal coat on top of the concrete, so you can't really see, but they did a nice job. I don't need full coverage with the rock. I need enough coverage just to carry things and let that next layer lay on top of it. And then here's a little video clip of the tom mix coming out of the truck. This is a HPG High Polymer Binder tom mix. That material just kind of flowing and kind of oozing out. This has got a very stiff binder, and we're making it at 300 and 325 or 30 degrees or so, making it process. And so we're going to take that material then and run that through an MTV, through a paver, then out behind the screed. So that's kind of what the material looks like. It flows. It looked like good mix. It looks like good mix. This is behind the screed. Now I don't have a lot of pictures and a lot of videos, but I've got a few. So this is the mix back there. We're running behind the screed right now. When we get that material up to temperature, we're running right around 300 degrees. And so that's kind of it seems to be kind of a key aspect of these high polymer binders. When they did the project on I-35 last year on right here in Kyle, they did a high polymer binder SMA, and that mix laid really good about 300 degrees right behind his screed. So again, you kind of get a sense of that. This stuff these mixes with these very stiff binders are not going to lay at cool temperatures. So that's an issue, but again, we've got opportunities where we can lay it. So this is what the material looks like obviously at night. You can tell it's got a nice texture moving along down the roadway. Here's another picture from the side. They've set their 10-foot level down there just to check things, a straight edge, just to check stuff. So again, they got nice texture. Again, we got temperature we got the right temperature. We're laying the material, etc., and the material's going down on the roadway. Here's a little, there's just another angle of it. Again, coming right out of the screed. So we're typically, when this material is running like this, it's about close to, 295, 300 degrees or so. And again, that's kind of what we see as being kind of a good number, okay? And then here's a video clip of the compaction operation. They had 2 rollers, again, working kind of in echelon with each other, which I think is a really good way of rolling a lot of mixes, particularly any sort of production mixes. And so they're up there coming up, moving pretty quick, and then compacting that material and getting it seated into place. Now the test results look good on this material. I don't have them to share with you, but I was able to look at them, and so everything did turn out well in the process. Again, this was some leftover binder that TXDOT, big thanks to TXDOT and Lone Star, worked out an agreement to go ahead and put this material on the ground to actually give us a little bit of opportunity to try it out. So, hey, that's cool. That's a great idea. And then here is the material that was laid. And this was rolled this week a little bit earlier. And I said, I'm coming back from vacation and riding on top of it. So this is the stuff that we laid. We were just a little bit back there where those pictures were, and so it looks good, rides really super smooth. Again, they did a great, the profiler that did the concrete work did a great job. Lone Star's on top of this with their crew. They did a really nice job with this paving as well. So again, great opportunities to knock some of the stuff out of the park. So what did we learn? We learned temperature's important. Okay, we learned temperature is super, super important with this material, and consistency is important as well. Will this limit where we can put it? Not necessarily, but it may limit when we can do it. So this is not going to go well in a really cool weather. Okay, so again, different applications for different things, but what we're finding out is we can take these binders that look like this, that are very, very stiff and have a lot of flexibility to them, and use them in our pavements that we can make things work out. Here's a chunk of, well, we're going to come to that here in a second. So anyway, that's just another opportunity that we've got going. But I would be amiss if I didn't tell you that over the 25 or 600 miles that I rode over the last week, I didn't look at the asphalt, and I looked at the concrete too. Okay, I looked at both, and you know what? I went from Texas, Oklahoma, Missouri, Illinois, and then back down again, seeing my mom. And there's some really good pavements out there, and there's some pavements out there that probably need some love. Okay, we can't fix everything and do everything up to the right level. But I will tell you, we've got one shot when we come out here and we got to work on these pavements. And I want to make sure that everybody understands this. From a design aspect out there, if we're going out and we're working on a pavement and we're going to put asphalt on top, there's the reason we're out there. From a design perspective, if we don't give the construction folks the tools to make that better, by proper surface preparation, level up, milling, profiling, whatever, we're not going to be able to make the pavement better. At best, we might be able to get it back to where it was. Why should we even be thinking about doing that? So from a designer perspective, you've got to be thinking about level up, thinking about milling, combinations of those things. Make sure we're doing the proper amount of patching. Make sure we're crack sealing at the right time and those things. So we give that pavement an opportunity to succeed. If we don't, it's going to fail. And I saw some new pavements on both sides that already had issues. And I think a lot of that, or a good significant amount of that, is actually coming from poor surface prep or no surface prep. Okay, and so that can be a challenge, but we've got to understand that. So then, we deal with the material side, et cetera, making sure we're using the right materials. If we're having an issue with the material and we take out that material, and we put the same material back in and we get the same performance, well, who's at fault there? Okay, the people that selected that material. We have other material choices out there. We have lots of mixes. We have lots of binders. We can help you with that. Give us a call. Talk to MTD. MTD is a Materials and Test Division, is a great resource. They're binder people, they're mix people, they're aggregate soils people. They got great people all over the place over there. So use them as a resource as you're making choices to figure out what you're doing and how you want to improve the performance. More people are moving, we're getting more traffic, heavier loads, more traffic's going up. Hey, things aren't getting easier for our pavements. So we need to make sure we give them all the opportunities for success. So anyway, just some things to think about. And then construction folks. Okay, I'm not giving anybody a pass today. Okay, we need to make sure that we construct this properly. If we have an issue, we need to fix it. Now, this mix, and like a lot of mixes, using these very stiff binders are sensitive to temperature. Okay, we need to be monitoring temperature with these mixes a lot. Okay, and trying to do that. That's why I showed you that picture behind the screen, because that's important. If we run out of trucks and we don't have a good system in there, okay, and that mix sits out there, as it cools, it's going to do what? It's going to get stiff. And as that material stiffens up, as the pavers tries to roll through it, paver's going to ride out there. So they had an issue. They fixed the issue. and the material had cooled off a little bit. They just moved the material to the side, reset, and paved on, and everything was fine. But we got to be a little bit careful about that when you're doing it. So inspection, communication with the crew, okay, inspector, contractor, make sure you're communicating frequently and all the time about these things, and don't, test it and check it and make sure it's okay. Now the real purpose of that job, the I-130 job, was to put an HPG binder, this sticky stuff, this really stiff stuff, in the PFC. That's the real choice. And so what we're able to do, again, the Tom was a side, kind of just a side thought. Okay, again, kudos to Lone Star and kudos to TxDOT for working that out so we could try that. But what they really wanted to do, they wanted to take a look at this stuff down here. Okay, they wanted to take their PFC and add that high polymer. This is just a chunk from the trial batch. We're going to talk about that here in just a second. But they were trying to improve the performance of those high polymer binders in the process. So here's a video of it at the plant. They did their trial batch at the plant, placed some material at the plant. Here's the material flowing out of the truck. So people say, hey, this material won't flow. You get it at the right temperature, you build it right, it flows. It's not a big deal. Okay. Here's some material behind the screed. Again, we're paving in a parking lot here, and so that's not necessarily the best of all the situations, but we're trying the batch and seeing how it goes through the paver. Okay. Now, just like the Tom, just like any mix, a SMA, a Tom, a PFC, or even a dense graded type material, the handling of the equipment, making sure the equipment and the plant and everything is up to speed and everything is maintained properly is really critical. These materials are going to stress the equipment. They're going to stress the pumps. They're going to stress the motors and all the systems in the equipment. So we want to make sure when we get to paving around and making these kinds of mixes and placing these kinds of mixes, everything is in good shape. We check our equipment out. We're not going to have an issue. So again, we want to make sure. So when this stuff first started, we were a little cool. Okay, so we had a little tearing, and that's, I'm just being totally honest with you, but once we got temperature and got heat in this equipment, everything is going well. It may be worth, okay, running some other mix through the equipment, through the MTV or through the paver, okay, just to help heat it up, okay, to help that heat loss. And you're going to run your heaters on your paver pretty much probably the whole time, okay, just to not heat it up, but to help keep the heat loss from letting that mix start to cool. So here's a picture of the FC5, or the PFC, excuse me, of that material placed. And then here's a zoomed in shot of it, and you can see, hey, it looks like a PFC. Okay, I was out there, did a little water test on it, and it flowed in less than 10 seconds. The water just right through it. Okay, so that's not a problem there. They waited a little bit even to roll a little bit, and it's still, everything seemed to set up right. So now this actually gets truck traffic every day. And so we will be able to kind of tell over a period of time how this material is actually working. But the test results indicated they did Canabro and water flow and Hamburg and the binder test and all that other kind of stuff. Everything passed. Okay, so and it has a very low Canabro test, which means that extra binder is really helping stick this stuff together, which is cool. And that's because that's one of the issues with PFCs is raveling. And so if I can have a really low Canabro test, which is basically tumbling a sample and seeing how much it breaks apart, a really low number there, hey, that's a good sign. That's a good sign. Maybe we're moving in the right direction. Now the big thing about this stuff is, will it rake? Well, it's tough. Not, being totally honest with you, the guys had to work hard on it. The longer you wait for this material, the harder it is going to be able to handwork or maneuver. But they were able to do it and got it to finish out and do what they needed to do in this area. So again, it's not easy. It is sticky. And so again, we want to make sure we've got scrapers and that's appropriate release agents, etc. in order to do that out. So again, we've got some anecdotal information from some other places. If you want to talk about that, give me a call or send me an email. We can talk about what some other folks are doing for keeping it from stick, and we'll be able to maybe help you out there. So what's the wrap up here on the Tom and the PFC Take-A-Ways? Well, again, these are simple concepts, guys, that we're going to cover, but they're really crucially important. Okay, the basics will get you most of the way there in paving. Okay. It's when we forget about the basics, then we get ourselves into trouble. Okay, so we always want to kind of keep coming back to that. So what's one? Modifiers. Okay, when we put modifiers in the binder, when we are trying to put a stiffer binder in there, it's going to increase the equipment demand. We talked about that. The plant equipment, the pavers, rollers, etc. We want to make sure everything's up and running, everything's in good physical shape and well maintained. Okay, that's a number one key thing. You don't, if a piece of equipment breaks down while you're paving, or the plant breaks down while you're trying to make the material, we're not in a good shape. Okay, so we want to make sure everything is well maintained before we get out there. Both Tom mixes typically laid at 1 inch. This was a Tom C, or a PFC, typically 1.25 inches, 1.5 inches. These are going to cool quickly, regardless of what binder is in them. Okay, but thin lifts cool quickly, which means you have less time to roll, which means we need to be all up about getting the business done when we're working with these products. When we modify it, it just makes it harder, not impossible, but it makes it harder. So we have to work a little bit more diligently there. When we put modifiers in the mix, our finish, or our time to where we're getting compaction, actually narrows a little bit. In many cases, what we're talking about here is going, typically thin mixes, you may have, maybe 10 to 12, 14 minutes, and now you're going to start losing time on that because your finish rolling temperature, wherever you'd start finish rolling, is now much higher. Okay, you're getting density rolling zone is actually increasing, maybe from 190 to 200, maybe to 225 or 235, or even up in that range. So you're losing some temperature because that mix is really starting to stiffen up. We got to get all over it. Okay, so when you add thin lifts and modifiers together, again, you've got a shorter window to do that. It's not insurmountable, but we just got to understand that we have a shorter window that we've got to keep track of. That's all. We can handle that. Now, do I want to be paving a thin lift with a modifier in December? No, I do not. I do not. I want to give myself the opportunity to do this and get it down. Again, we're paving at night. Night takes time away as well, so we've got to be watching that. But again, opportunities. Heat helps, but we don't want to overheat the binder. So I don't want to just go ahead and jack the temperature way up, okay? Because that actually, at some point, you start damaging the binder itself, which takes life out of the pavement. So you're kind of counter defeating yourself. I want longer life, so I'm using better binders, but I overheat it and then I get less life, so I'm just got really expensive stuff out there that's not really giving myself any other benefit. We need to pave consistently. So we need to produce the material, we need to haul the material, we need to pave the material consistently. We don't need to be big, we don't need to run out of trucks. You may want to over truck if you get into this. I know I just said a bad word, but we want that paver to be moving, okay? And we want to keep the operations tight. And I would keep a loader out there just in case I needed to use it, okay? And I think that's just a good rule of thumb out there. If you get in a situation, you don't have a loader, you try to shovel everything by hand. By the time you get done with that, you got a problem. Keeping a loader handy is a good thing, okay? So, thin lifts, PFCs, or Tom mixes, PFCs, different binders, a lot of stuff going on. We can do this. We can do this. Other people can do it. Heck, Texas can do it. Why not? We're gonna rule with this. The other thing that's been happening, and this is something I've been working on kind of by myself for a long time, and other people have as well. There's test sections at NCAT. There's South Carolina is using this. Oklahoma is now using this kind of concept, is going to thicker lift paving. Well, what's thick lift paving? Thick lift paving is not 2 inches. Okay, thickness to paving is not 3 or even 4 inches. Now we're talking 5 to 6 inch lifts one pass, one paver. Oh, everybody's going to go, oh, you can't do that. Well, we can. It's been done. It can be done it's done a lot, okay? And so we just need to do that. But can we do that with some of this HPG mix and really develop us a really monolithic super slab of asphalt out there that's really going to kick butt and take care of the traffic? So that's what we're able to do. Again, big shout out to Lone Star, TxDOT, for jumping in there. They pulled extra samples to test this material, etc. And so what they did is, here was the premise. Can we lay asphalt 6 inches thick and get density? Okay, so what Lone Star did, and again, big thanks to them, they milled up part of their parking lot, their entrance to their asphalt plant. We went and we paved. Okay, so they milled almost 20 feet wide, like 19 and a half feet wide, and this is about 100 foot long, thereabouts. I can't remember exactly. And so they got it all ready. They tacked the edges and all that kind of stuff, and then they paved it. Okay, they paved the 6-inch lift. That's compacted, not loose. Okay, that's not loose. And so obviously sometimes we get in a hurry, sometimes we have to do a little extra handwork. That happens. Okay. This would typically, application would not be a finished surface, it would be a lower layer, so we can work some of that sort of stuff out. But again, they pulled off the joint, got some stuff coming, paved up, came back, paved the other side, and they were done in a pretty short period of time with this material. Again, 6-inch compacted lift's gonna mix goes a long way and do that. But this is summer. This was in July. So what's going to happen to that temperature? So it's going to hold heat. Okay, so this is a cross section of the pavement. Okay, this is now 7.5 inches loose, 6 inches compacted. This is a thermometer, probe thermometer, in the mix in the middle of that once they laid it. And we're 310, 315 degrees in the middle. Now this material is going to hold temperature for a while. Okay, actually quite a while. Okay, and that's the one thing that we're going to have to control as we move on down the roadway in the process. So again, there's another picture of it, of the material. We're going to get that. We got, you know, in this case, if you do about 1/4 inch per inch, you need to be about 7.5 inches to the top here. And so this is about 1.5 inches. This material is going to compact to get it down into the hole in there. And then again, I apologize for not getting as many pictures. I was running around doing a bunch of stuff, but they came out with a vibratory roller, and they made 4 passes over the material. And they came out with a rubber tire roller, big rubber tire roller, and they made multiple passes across that. And they came back with a finish roller and then finished it out. Again, this is the entrance, so this is going to get a lot of traffic. Rock in, mix out, okay, in the process. So it will be interesting to see how this performs. But indications are, based on other performance in other places, this stuff's going to be a rock star. That's going to be a rock star. So again, we go back to the question: can you lay 6 inches and get density? Okay, so here's my sample right there. Okay, that's 1 core. Okay, this is 1 core. Here's my roller. Can we get density? And they actually cored that sample. They split it in half. They tested the top and tested the bottom. Okay, so again, it was laid in 1 lift. Let me get back over here. And how did they do? Well, let me get out of the way. So they did 2 cores. The first core averaged 4% in place air voids. That's pretty darn good. People say, well, this stuff won't compact. Okay. The second core, it was 3.9%. Really consistent. Okay. They split it. The top half was 3.7. The bottom half was 4.2% air voids. Okay. On the second core, 3.3, 4.4. But if you look at say, hey, they're not the same. Yeah, but look at the density we got out of the bottom. Okay, that's pretty darn good in the big scheme of things. So we are able to get it. And think about, I no longer have an interface in here. I can lay the mix quicker. I can get it done faster. So that gives me some opportunities. So what might be our options for use for this material? One is a deep rehab, a rapid rehab. I've got a problem with the pavement. I want to be able to go out there. I can go out there with a milling machine. I can mill down 6 inches or whatever I want to do. I can come back and I can put a 6-inch compacted lift in there. I can let it cool, and then I can let traffic run back on it. Okay? So I'm going to need a little bit more time to let it cool. Understand it? But in many cases, in some parts of the state, they're taking asphalt out, they're putting concrete. How long does concrete take? Well, we're not talking hours, we're talking weeks. So it's a little bit different thing, but if we want to fix it right, this might be an option. Heavy duty pavement applications. Again, Texas is growing, we've got more traffic, got heavier loads. This might be part of our solution for laying thicker lifts and getting stronger pavements out there to really help carry the loads. Perpetual pavements. Perpetual pavements are designed to minimize the strain on the top of the subgrade and minimize the tensile strain on the bottom of the asphalt. Okay? With some of these type modified binders, they're not going to crack. And with a thick enough slab, they're not going to damage the subgrade. So you get in the situation where you never have a problem with the base. Any distress that you have long term ends up at the top, and I can mill and replace that overnight. So that's really kind of the concept of a perpetual pavement. Rapid intersection reconstruction. Again, we just talked about that. So there's an option there, I think, to maybe go in and fix these problems. A lot of times in intersection, we're going, hey, it's rutted, we're going to go rip off the top 2 inches and put 2 inches back in. But if the problem is down deep and we really need to fix it, we're going to need a little bit more time. But maybe with this technique of going in and milling in, putting that first slab in there, maybe come back and do some profile milling on top, and then put another wearing course, if you will, on top of it, may give us some more options in wear. I think there's a great benefit in here for speedy construction. Great benefit in there. And then just stay tuned. Stay tuned. Again, big thanks to everybody involved in here. MTD, UT's is doing some additional testing on these materials as well. Big thanks to everybody that's out there. So again, trying to wrap things up here. Everybody's kind of busy. But again, a lot of stuff going on. Okay, so again, simple concepts in here. When we start talking about modifiers, this is not your dad's asphalt, not my dad's asphalt. These are different. They're going to have to be handled differently, but what they bring to the table, I think, is the potential for significantly increased performance. So we just got to don't be afraid of this stuff. Don't be, as Chuck Fuller would say, don't be scared, because this stuff can work. So great opportunities out here with a lot of this material. And we got stuff on the ground. We're testing it, and a big thing again. Thanks to TXDOT for trying stuff, let's see how we can make it work. Again, big thanks to TXDOT, MTD, TXDOT Austin, or Austin District. Again, big thanks to all those folks as well. So, anyway, so that's kind of wrapping it up here. Again, the purpose of the the purpose of this session here today is to talk about things that are going on. And so our road trip this month not only looked at getting people into the industry, but also looked about modifying binders, modifying mixes to actually make mixes better. And again, that thick lift, again, that was a type C. That was a dense graded material. That wasn't super paved. That was just a dense graded material. So again, we've got lots of options out there that we can do things in the process. Don't forget the Everyday Asphalt. Again, we post these on our website on YouTube. We also put them on Spotify and Audible as well. Remember to like, subscribe, and share. And that's it for today. I hope everybody is safe out there. Have a great summer. Stay hydrated. It is summer and all that. And we look forward to seeing you very soon. Take care, everybody. Ever forward.